everyone, in this video we're going to be talking about systems of nonlinear equations. So we spent a lot of time working with systems of linear equations in the last video, and so we're going to be doing nonlinear systems using substitution and elimination. Alright, so we're going to just do a handful of examples so you can see how this goes. So here's a system where one of the equations is linear, number one, but the second one is not. And it's linear if when you draw it you get a line. Also, you can tell if an equation is linear if the degree or the power on the variables is invisible 1. So that's linear, but the second one has an x squared, so this one's not linear. Notice if you graph these two equations, they do intersect in 2 points. So that means that this solution to this system of equations has 2 answers. And so we're going to go ahead and solve this. So let's use a substitution method. And so what we're going to do is we're going to go ahead and substitute from equation 1. We're going to solve for y and plug it into equation 2. From equation 1 we knew that y was 2x plus 4. And so exactly in this spot from equation 2, you just replace it with what y is equal to. And then the good thing after you do that, this is how you kind of check if you're on track, you should have an equation with only one variable in it. And so notice at this moment we only have x's in our equation, which means we can solve for x. So at this step we're just trying to solve this equation, and notice it is a quadratic equation, so we can factor it. If it's not factorable, you can try the quadratic formula, but this one you can factor out a 2, and then what's left would have been x squared minus x minus 2. And so that factors to x plus 1 times x minus 2. And then we have a zero product property that says either x plus 1 equals 0 or x minus 2 equals 0. And then just solve both for x, and you get x is negative 1 and x is 2. Okay, so once you have those numbers, we have x was negative 1, we had x was 2, we need to go back and find y. And so if you plug back into either equation 1 or equation 2, this is our equation 1, just rewritten in terms of y. So if you just plug in exactly where there used to be an x, because that was this equation here, you're going to find that y is 2 and that y is 8. Okay, and so you have to put these solutions together. When x was negative 1, y was 2, and then when x was 2, y was 8. And so those are the solutions to our system. And it's always a good idea to check. You want to check just to make sure that you didn't do anything wrong, or that even if you did everything correct, one of the possible solutions wasn't what we call extraneous, meaning that it just doesn't end up working out because of some algebraic steps that we ended up taking, like squaring away like a radical and things like that. Sometimes we have extraneous solutions. So when we plug those in, it does work out. Into equation 1 and 2, we get the correct answers. Same thing for the second one. And then if you look at the graph, those ordered pairs for x and y, they actually line up with the picture of the graph at those 2 points of intersection. So that looks visually also correct, but we solved it algebraically. Okay, let's go ahead and try another one. This time we're going to use the elimination method. So you have 2 equations, neither one of these are linear this time. One's a circle. If you graph equation 1, this one's a circle. And if you graph equation 2, this one is a parabola. And so if you want to take a look at what the graphs look like, you have your circle centered at 0, 0, the radius is 2, and you have this sideways parabola opening to the right. And these 2 graphs meet at 4 different points. And so there's apparently 4 solutions to this system. So that's what we're going to expect, but we're going to solve it algebraically. So let's go ahead and use elimination. And if you notice, if we just subtract the second equation, so if we basically multiply this by a negative 1, and then we subtract it from the first equation, then the y squareds are going to add up to 0. Okay, so we'll do that. So if we multiply the second equation by negative 1, that becomes negative y squared. The negative distributes and you get positive x, and then the negative goes here and you get negative 4. And so the y squareds add up to 0, these add up to 0, x squared plus x, and then equals to 0. And this is always a good point to notice that we're on track because we have one equation with only one variable, so we can solve that for x. And so this one factors really quickly. We just factor out an x, and then we say that either x equals 0 or x plus 1 equals 0. So just a step in between here would be x plus 1 equals 0. And so those are our two values for x. Now what we want to do is we want to find the corresponding y values. So let's go ahead and take our x values and plug them back into equation 2 where we have an x. So if we put x equals 0 right here and try to solve for y, we're going to get y squared equals 4. So if you take the square root of both sides, you actually, whenever you do this, you have to put a plus and minus, because when you square something, even if it was negative, it turns positive. So if you go backwards and take the square root, put the plus and minus. And so there's two solutions. When x is 0, y is positive 2, but it's also negative 2. Okay, and then when x was negative 1, same thing, plug it into this equation. We picked equation 2, put it in the spot for negative 1. And then if you solve that, you just say y plus 1, negative and a negative. And so when you subtract that from 4, that's how you get y squared equals to 3. And then take the square root of both sides, put your plus and minus, and then that's how we get y equals square root 3 and y equals negative square root 3. And so here's our four solutions. When x is 0, y is 2, y is also negative 2. When x is negative 1, y is square root 3, and also negative square root 3. And then you can verify these by plugging them into the equations. And then visually we can tell that actually those are the 4 points of intersection of our two graphs. Alright, let's go ahead and try another one. Okay, for this one, the first equation is actually what's called a hyperbola if you graph it, and the second equation is a parabola. Okay, and then if we look at this, we can use either elimination or substitution. They'll both work on this system. And we're going to go ahead and use substitution. Let's go ahead and substitute equation 2 into equation 1. And so if we do that, we will get that x minus x squared equals 4, because we just put x right here where there used to be a y squared, because that's what equation 1 was. And then notice that's good because we have an equation with only x's in it, only one variable. And so notice it is a quadratic equation, so bring all your terms over to one side. And so we just add x squared to the right, subtract x, and that's how we get that version of our equation. And then for this one, you can focus on just the discriminant if you were to use the quadratic formula. But if you didn't recognize that, you can just go ahead and use a quadratic formula for the whole thing. But you're trying to solve this equation, and if you try to factor it, you're going to have a hard time. So if you go to the quadratic formula, you would have negative b plus and minus square root b squared minus 4ac, so just over 2a. Just a reminder that this part under the radical is what we call the discriminant, because it tells us about the nature of our possible solutions, if we have real numbers, irrational numbers, or no number at all, like if it's imaginary. And so if we start to plug in these values for a, b, and c, notice a is invisible 1, b is negative 1, and c is 4. Then we plug that into just the radical part, the discriminant, and we're going to get negative 15. So if we have a negative 15 right there, taking the square root of something negative, we can go ahead and just stop, because that's going to be imaginary. And those are not real numbers, and we're interested in real numbers for our solutions. So this system has no real solutions, and it is inconsistent. So no real solutions to this system. And remember, when there are no solutions, we say that the system is inconsistent. Visually, if you take a look, you can tell why now, because there's no intersecting points on these graphs. The parabola was our second equation, the hyperbola was the first equation, and the two never actually intersect. Alright, let's try another one. So let's use the elimination method this time. So we have two equations here, and there's a lot going on with both of them. On the first step, let's go ahead and just not have to deal with this fraction anymore. So multiply this entire equation by the denominator y. So you're basically going to distribute y to all of these terms on both sides of the equation, and that way you don't have to deal with a fraction. But keep in mind that y used to be in the denominator, so y can't be 0. So if it comes up in any of our solutions, we just have to say, well, it can't be 0 because y used to be in the denominator. So this is our new version of number 2. This looks a little nicer to work with, so that'll be easier for us. Now we can go ahead and use elimination if we just multiply equation 2 by -1. So if you distribute -1 to all your terms, then let's go ahead and do that real quick. So I'm just going to distribute -1 to all the terms, and so that's going to look like -y squared minus y minus x plus 2, and this is still 0. And so if we just add that up from there, the y squareds add up to 0, the y's add up to 0, we have an x squared, and then negative x minus another x, so that's minus 2x, and the 2's add up to 0, and then this still equals 0. So that's the result from elimination. And this one factors really nice. Notice it is just one equation with one variable, and we just get x is 0 or x is 2. So now we just have to go back and solve for y. And so plugging into either of our equations, we're going to solve for y. So we know x is 0, so exactly in all of these spots for x, let's plug in a 0. And then we are going to have, after that, y squared plus y minus 2 equals 0. So we didn't get a number, not yet at least. So even though we plugged in x, like our other examples, this time we have to do a little work before we can get to the final values for y. We still actually have to go from here to here by factoring. And so then when we solve for y, we get y is -2 or y is 1. Alright, and then if we check those values, plugging into equation 2, we'll see that they do work because equation 2 needed to equal 0. So that looks good. That's us checking, making sure we didn't do anything incorrectly and our answers weren't extraneous. But we also got that x was 2, so we're not done. We have to go ahead and find y when x is 2. So plugging in right here, plug in x is 2, and then we end up getting a quadratic equation again that we're going to have to factor. And so that one factors as y times y plus 1, and then you get y is 0 or y is -1. But hopefully you remember something. We said early on, this actually is a problem. Y can't equal 0. But we found it normally. We didn't do any errors to find this. So what we say is we call that answer extraneous, because even though we did it algebraically, we found that correctly doing our work. Originally, it's not going to satisfy those equations, at least the second one. So we have to just discard it. And so if we just check when y is -1 and x is 2, then that one checks out. And so then our solutions are when x is 0, y is -2, x is 0, y is 1, and then when x is 2, y is -1. And if we were to graph the equations, those would be the 3 points of intersection. Alright, let's go ahead and try this one. So we have a system, notice the second equation is linear, the first one is not, and we're going to go ahead and use substitution on this one. And so let's rewrite equation 2, and you can solve for either variable. You can solve for x or for y, and we're just going to solve for y. But just note, you can solve for x also. So it's just a choice. So we're solving equation 2 for y, and then we're going to plug it into equation 1. So exactly where there's a y in this equation, we are going to replace it with what y equals. We just solved for y was equal to 5 minus 2x over 3. So that's going to go in those spots. Make sure you use parentheses, because that way you're not going to mess up on any steps after that where you have to do some algebra. So this part comes from a few steps. So let's start with this one. If we just distribute -3x here and here, notice that the 3's will divide out. And so that's going to be basically -x times 5, which is this term, and -x times -2x. And so that's where positive 2x squared came from. Now this one over here, order of operations, you have to square this first. And so you do have to FOIL that numerator out. So you're going to have 5 minus 2x times 5 minus 2x. And then the denominator is also going to get squared, but that's the 9. So when you square the numerator, that's what we have up here. When the denominator gets squared, that's going to become 9. So those 9's are actually going to divide out, that 9 with this one here. And so if we FOIL this out, we're going to get 25 minus 10x minus 10x plus 4x squared. So that's 25 minus 20x plus 4x squared. And remember, this 9 divided out with the 3 squared. And so then that's how we got that step. And then we just want to combine like terms. So let me use a new color here. We have x squares that we're going to combine. Notice that we have a total of 10 of them. And then we have x's, minus 5 of them, plus 20, minus 20 of them, so minus 25 of them. And then we have 25 and 15, so if we just subtract 15 from both sides, that's where we get 10 from. Alright, so that's how we simplified that one. And then we can go ahead and make our life slightly easier by just dividing everything by 5. And we have a quadratic equation. So from here, you would say, okay, this is a quadratic equation now. It's of my form ax squared plus bx plus c equals 0. And if you look at it and you can't factor it, just go to your quadratic formula. But if you can factor it, that's usually faster. So this one does factor. It factors as 2x minus 1 times x plus minus 2. And then if you solve each one, set them equal to 0, we get x is 1/2 and x is 2. And then now let's go ahead and find y. So we had solved the equation, this is like our modified equation 2, and we solved it for y, and so let's go ahead and just plug in the fact that x was 1/2 right into this spot right here. And so if you plug that in, negative 2 divides out with 2, and you're just going to have 5 minus 1, so that's why we get 4/3. And when x is 2, just plug that right in, and we're going to get that y is 1/3. And so we have two solutions. X is 1/2 and y is 4/3, and x is 2 and y is 1/3. Alright, that's it for this one. Thanks for watching.